This is an equivalent circuit of a solar cell or even a solar panel. We'll use the same circuit to represent both. This is an ideal current source powered by the sun, and the current value is proportional to the watts per square meter hitting the solar cell or solar panel. This is a diode facing downward to ground that represents the diode characteristics of the solar panel. RSH is the short circuit or shunt resistor, not short circuit, shunt resistor that represents the leakage losses in a solar diode. RS is a series resistance that represents all the traces and contacts and even a little bit of the diode resistance. And the product that we're looking for is V out plus I out, and I out would be going that direction. This part of the circuit is called a node, and all the currents going into this node is equal to all the currents leaving that node. Now the interesting thing is ID going through the diode is a certain value around 0.6 of a volt, or VD is around 0.6 of a volt, and this current is determined by the temperature of the solar cell. This current is relatively fixed, okay, and the ideal model would set R shunt to infinity and R short circuit to 0. And since this is usually a very, very small value, that's a pretty good approximation when testing things. So we got the sun coming in, the photons are being turned into a current. Current goes into the node, down the diode path, ideal diode path, and down the shunt resistor path. If we have a load out here at V out, we would have a current going through the series resistor. Stop.